Hello everyone. In this video, I wanted to show you how you can simulate the behavior of an AND and OR logic functions using pneumatic circuits. So for this purpose, I already placed in here in FluidSim three main elements. I have the single acting cylinder, and here I am placing the air source of the pneumatic circuit, and this air source is connected to port number 1 of two directional control valves that consist of two positions and three ports. Okay? And well, I will place here the actuation mechanisms of these directional control valves. So you can double click on this first directional control valve. Then you need to go to the left actuation mechanism. And I want to control this with a button. So in this case, I will be using an interlocking button, and you click OK. And also I want to switch for the second position with a spring. So you click here in the option that says spring reposition, and then you click OK. And I will do the same for the other directional control valve. Okay, you place here a button, an interlocking button for the left actuation, and for the right actuation, I will be using a reposition spring. And you can notice that the actuation mechanisms are shown here in the symbol of the directional control valve, and then you click OK. Now, one of the things that I wanted to make is to establish the way in which we can simulate the behavior of an AND logic function. So for this purpose, we can use a different type of valve that is called the two-pressure valve, okay? Or simultaneously, or two, well, in English, it's called a two-pressure valve, and it has the following symbol. The interesting part of this valve is that, well, you have three ports. You have one port in the left side, and you have another port in the right side. So the way in which this valve works is that you need to apply air into this port and to this port at the same time in order to allow the airflow in port number 2. Okay, so I will connect port number 2 of this two pressure valve to the single acting cylinder that is in the section, and I will connect this port to one of the outputs of one of the directional control valves, and I will connect in the other port to this section. Okay, and now I can start the simulation. So I want you to notice that, for example, if I push this button, well, the air will be flowing from the air source to these ports, okay? But you can notice that the cylinder is not extended. So I need to press also this second button. And it's only when I apply pressure in these 2 points that the air is flowing from port number 2 to the chamber of the single acting cylinder. And the air that is applied to this section is applying a pressure that is extending the single acting cylinder. Okay, but when I stop pressing one of these buttons, you can notice that the airflow that flows through this connection disappears. Okay, so this only works when you apply pressure in the 2 points of these two pressure valves in order to allow the pressure or the air pressure to flow from port number 2 to the air to the chamber of the single acting cylinder. Okay, so this is the way it works. And there is another valve that we can use by using the same configuration that is called the shuttle valve. Okay, this shuttle valve has this following symbol, but this shuttle valve behaves very similar to an OR logic function. So you can connect this element to this port, okay, and also you connect this port to this section and this port to this section. And well, we can start the simulation. And you will notice that this valve will allow the airflow from port number 2 to the air chamber of this single acting cylinder. If I press this button, okay, there is an airflow. Okay, but also if I press this button, there is also an airflow, or I can push the two buttons and the air is flowing uh, from the shuttle valve to port number 2, and then it goes to the chamber of the single acting cylinder. But it applies the air always, regardless of which button is pressed or the two buttons are pressed simultaneously. Okay, the only scenario in which the piston is retracted is when there is no air input in the two ports, in the two port labels as port number 1 of the shuttle valve that is shown here. Okay, so you can notice that it is very simple to simulate the behavior of an OR and logic function using these type of valves. Remember that this type of valve is for an OR logic function, and this is called the shuttle valve. And the other valve that I used previously is the two pressure valve that allow us to simulate an AND logic function. So that's all for this video. I hope you like it and see you later.